I'm going to talk to you today about the physics of baseball, which was a talk given by Dr. Alan Nathan from the University of Illinois. One of the first things that we can learn from watching baseball is conservation of momentum. When a bat hits a ball, the bat is transferring momentum to the ball in the forward direction, whereas the ball is transferring an equal amount of momentum to the bat. And this is actually a very inefficient process because a lot of kinetic energy is lost due to the fact that the collision is inelastic. So during this time, this very short amount of time of this collision, around 1 millisecond, very large forces are created. And this can be explained because to turn this ball around in 1 millisecond, a very large acceleration is needed. And according to Newton's second law, if there's a very large acceleration, then very large forces are created as well. So the physics of this collision is very similar to the physics of a spring. So when the ball hits the bat, it compresses and the kinetic energy is turned into potential energy. Then it halts and then it expands back again and the potential energy is created or converted back to kinetic energy. So this actually, as I said, was really inefficient because the ball is being deformed and also the bat is creating vibrations and it's going to recoil. So a lot of energy is lost this way. And fun fact, if you whack a ball and then you retrieve it, you can put your cheek to it and you can feel where the ball actually was hit by the bat due to the fact that it's hotter in that area since the energy is being transferred to heat. So that's pretty interesting. Another important concept I learned was about coefficient of restitution. So coefficient of restitution is basically the ratio of the outgoing speed of the ball once it's hit to the incoming speed of the ball. And this basically measures how elastic this ball is. And it's pretty cool because before the season, they would test all of the balls to make sure that they have all the same CORs so that, in some games, like the balls shouldn't be, a lot better than the others or shouldn't be easier to hit home runs or anything. So they would always check that. So another interesting thing to think about is what affects batting ball speed. Well, three things actually. There's pitch speed, there's batting speed, and also there's collision efficiency. So the formula that he uses is BBS, or batting ball speed, equals Q times V pitch, and then plus 1 plus Q times V bat. In this equation, you can see that V bat is more important than V pitch because there's a 1 plus Q as the coefficient rather than just Q. And this is mainly because the ball or the bat is going to be in the forward direction, exactly the same direction that the ball is finally going to be hit. So the ball is going this way, but the bat is going in the forward direction already, so that has more weight in the equation. So another important concept is moment of inertia. And when I'm talking moment of inertia, I mean where the heaviness is centered in the bat, and that should be in probably the center of the barrel, 6 to 7 inches from the end. And the importance of the heaviness of the bat is that it has a higher collision efficiency. So lighter bats create more vibrations and they're losing a lot more energy, creating more recoil. So the ball won't move as fast. Whereas in heavier bats, the collision efficiency is a lot higher. But the thing is, when a bat is heavier, that means that you're going to swing less fast. So your V-batting would be a lot lower. So you'd think, okay, what's more important, the heaviness of the bat or your V-bat? And that really depends on what you think is more important, because in a heavier bat, you can hit more home runs because less energy is being lost. But also, if you have a high V-bat and your bat is lighter, then you can swing faster, and that means you can wait for the pitch to come, and you can watch it, observe it, and then change your pitch accordingly. So if you want a higher batting average, then you might want a lighter bat, which Sammy Sosa used to do. He used to cork his bat so that people would think it's just a wooden bat, but it'd actually be lighter, and he had a really high batting average, but that's illegal. So another important question that he tackled was whether aluminum bats are better than wood bats. And the answer is yes, because the aluminum bats made out of a thin hollow shell of aluminum, and this creates what is called hoop modes. And these are modes of oscillation where the bat is being compressed. So in a wooden bat, the material is virtually incompressible. So when the ball hits it, the ball is being compressed a lot and it's being harmed a lot. But in an aluminum bat, the bat is the thing that's being compressed. The surface is being compressed a lot more than the ball, and this is called the trampoline effect, so it just bounces off. So that's why aluminum bats, might be better than wooden bats, and batters prefer that. So I'm running out of time, but that is a lot of the stuff that I learned, and I had a really great time watching Dr. Nathan's talk, so I thank him for that, and I hope you learned something today. Thanks.